On April 17, 2025, a groundbreaking paper titled New Constraints on DMS and DMDS in the Atmosphere of K2-18b from JWST MIRI was published in the Astrophysical Journal Letters. Researchers from the University of Cambridge, using data from the James Webb Space Telescope, detected the possible chemical fingerprints of dimethyl sulfide, DMS, and/or dimethyl disulfide, DMDS, in the atmosphere of the exoplanet K2-18b. Here on Earth, DMS and DMDS are produced only by living organisms, making them strong candidates as biosignatures. If confirmed, this detection would be one of the clearest clues, yet that complex, carbon-based life might exist beyond Earth. So, could this be the closest brush we've ever had with extraterrestrial life? Welcome to mindgap. In this video, I want to share my thoughts and feelings about this astonishing discovery and what it means for us as a species. If you're new here, don't forget to subscribe for more interesting content. K2-18b orbits a red dwarf star located 124 light-years away from Earth. It's about 8.6 times more massive and 2.6 times larger than our planet. Most importantly, it lies within the star's habitable zone, a region where conditions might allow liquid water and potentially life. In 2019, astronomers discovered water vapor in its atmosphere. In 2023, JWST detected carbon dioxide and methane, painting a picture of a planet covered by oceans beneath a hydrogen-rich sky. Now, in 2025, comes perhaps the most exciting clue yet: signs of DMS and DMDS. So, how can we detect DMS and DMDS on a planet 124 light-years away? The key is infrared spectroscopy. The James Webb Space Telescope is equipped with a powerful instrument called MIRI, the mid-infrared instrument. It analyzes light, specifically infrared light, which is invisible to the human eye. When K2-18b passes in front of its star, some of the starlight filters through the planet's atmosphere before reaching us. Different molecules in the atmosphere absorb specific wavelengths of that starlight, like a molecular fingerprint. The James Webb Space Telescope collects the filtered light and breaks it down into a spectrum. Scientists then found absorption spectra that matched theoretical models of DMS and DMDS that suggests their presence in K2-18b's atmosphere. In other words, we're not seeing the molecules directly. We're seeing their tiny fingerprints they leave on starlight. It's really an exciting discovery. But let's slow down and figure out, what do we actually know? First, we need to be cautious. Right now, the statistical confidence for the DMS and DMDS signal is not strong enough for a confirmed detection. The chance that this signal is a fluke is about 0.3%. And in science, that's still far too high. For something to be considered a solid discovery, that number needs to be less than 0.00006%. Second, while DMS and DMDS are only produced by life on Earth, we can't rule out non-biological chemistry happening on a completely alien world. In fact, other teams have demonstrated that DMS can be produced by UV light shining on hazy, simulated exoplanet atmospheres. Some astronomers even claim to have found DMS in the gas and dust between stars. So, is DMS really a reliable sign of life? Professor K2-18b, who led this study, pushes back. He points out that the concentration levels of DMS and DMDS in K2-18b's atmosphere are thousands of times higher than what we see on Earth, far beyond what photochemistry can explain. Here on Earth, DMS is usually just 1 part per billion, but on K2-18b, it could be over 10 parts per million. Professor K2-18b is hoping to conduct further theoretical and experimental work to determine whether DMS and DMDS can be produced non-biologically at that high level. So the debate continues. Until we have stronger evidence, it remains uncertain whether these molecules truly indicate the presence of alien life, or just some bizarre chemistry we haven't discovered yet. Then there's the issue of distance. K2-18b is 124 light-years away. That means any light, or data, we receive today actually left that planet 124 years ago. Even if life existed then, we have no way of knowing what's happening now. And visiting this world? Don't hold your breath. NASA's New Horizons is traveling toward Pluto at 16.26 kilometers per second, which is already humanity's most advanced spacecraft. But if New Horizons is to travel from Earth to K2-18b, it will take 2.3 million years. By then, who knows if humans will still exist? Humanity's exploration of the universe always echoes with a deeper, more haunting mystery, the Fermi Paradox. Given the vastness of the cosmos, with billions of galaxies, each containing billions of stars, and even more planets, intelligent life should be common. And yet, we've heard nothing, seen nothing. No signals, no visitors, just eternal silence. If intelligent life exists out there, why haven't we found any trace of it? Scientists have offered many explanations. Some believe that advanced civilizations tend to self-destruct before reaching the stars, through war, environmental collapse, or runaway technology. Others suggest that alien signals may exist, but we're simply too primitive to recognize them. Perhaps intelligent life is watching us from afar, choosing not to interfere. Like zookeepers behind glass, they observe silently, waiting until we reach a level of maturity worthy of contact. And the most unsettling possibility, that Earth is the exception, and we are truly alone. Whether life exists on K2-18b remains unclear. But one thing is clear, the pursuit of this question is worth it. Compared to the vastness of the cosmos, the political squabbles and power plays on Earth often feel small, exhausting, and meaningless. Have you ever felt the same? When I reflect on the scale of the universe, I'm struck by how fragile and fleeting humanity seems. It is a feeling of powerlessness that comes from the depths of the soul. But I'm also moved by our potential, by what we've accomplished. In just a blink of cosmic time, we've gone from caves and fire to satellites and space telescopes. Our greatest strength is our imagination, our curiosity, our hunger for the unknown. Over the past 3 centuries, technological revolutions have transformed our world. But now we're stalling. The next leap, the one we desperately need, still hasn't arrived. Meanwhile, the global economy is faltering. Inequality is growing. Populism is rising. And countries are locked in an endless struggle over resources and interests. But these fights won't save us. What humanity needs now is not more conflict, but more innovation. We're waiting for a new technological revolution to emerge. One that can lift productivity to new heights and help us address the widening gap between rich and poor. To achieve that, we need better universities, better scientists, and long-term thinking. Politicians like Donald Trump, pointing the axe at Harvard University, is undoubtedly a major blow to academia and scientific research. As the old saying goes, people who fail to plan for the long term are unfit to manage the present. Who lack a vision for the whole are unfit to handle a part. I hope this discovery by Cambridge serves as a reminder, a spark, for both the public and those in power. Our future doesn't lie in endless competition over land and oil. Our future lies among the stars, in the great, uncharted ocean of the universe. That's all for today. If you enjoyed this video, don't forget to subscribe and leave your comment. This is mindgap. See you in the next video.